Hey everybody, in this video we're going to talk about composite functions. Before we get into the actual function notation, I'm going to use an example of something that you might be familiar with to kind of show you how this whole thing works. At the very basic, most simple way of thinking about functions, it is when the result of one function is used in another function. Now we can use this idea in multiple ways that we're about to see, but that's the most basic idea. Now, before we get into the function notation, I'm going to use that an idea that we've talked about, and that's called arithmetic sequences and series. We're going to talk about both real quick. If you're not familiar with arithmetic sequence or series, you can check my other videos, and they go into it a little bit more in depth. I'll do a very fast review here of what it is, but if you want more information, check my other videos. So an arithmetic sequence is when you have a sequence of numbers. So here we've got 2, 7, 12, 17, and we can assume that it continues on from there. And with this sequence of numbers, we are going to try and find the 25th term in the sequence, and we're going to try and find the sum of the first 25 terms in this sequence. So our sequence, our arithmetic sequence, we have a formula for that, and that's u of n equals u of 1 plus n minus 1 times d, where u of n is a term value that we're trying to find. Okay, so that'd be like the value of the 25th term in this case. U of 1 is the first term in the sequence. Okay, n is the term number of the term that we're trying to find, so in this case 25, and d is our common difference. So the common difference is how the values change from one to the next to the next. Along with this, we're trying to find the sum of the first 25 terms, so that's where we use our arithmetic series. Our arithmetic series is a little different because this is where we actually talk about the sum of all of the values up to a certain point. This formula is s of n equals n over 2 times u of 1 plus u of n. Okay, and in this case, s of n is the sum up to a certain specific term number, and our n, our u of 1, and our u of n are all the same thing as above. The term number, the first term, and the term value excuse me, of the highest term that we're looking at. Okay, so as we try and find u of 25, we're trying to find the 25th term, the value of the 25th term. First thing we have to do is start plugging in our values here. So we've got 2 plus 25 minus 1. So 2 is our first term, 25 is the term number, so n is 25, so 25 minus 1. And then we have to multiply that by d. So we have to think about how does this thing change from one term to the next. Well, as you can see, we're adding 5 here, and then we add 5 again, and we add 5 again. So our common difference is 5, so we'll multiply this bit by 5. Do some very basic arithmetic here. 2 plus 24 times 5, we get 2 times 120, so our 25th term is 122. Now, what are we going to do with that 122? Well, we found that that's the 25th term in the sum of the sequence, the 25th term in the sequence. Now we want to find the sum of all the terms 1 through 25. So we can use our arithmetic series formula. So s of 25, the sum of the first 25 terms, is going to be 25 over 2, n over 2, times u of 1, which is 2, plus u of n, which is 122. Again, just doing some basic arithmetic here. 25 over 2 times 124, and that equals 1,550. So there we see that we use the value of the arithmetic sequence to put into the arithmetic series. And now that's all fine if we only have to do one problem like this, but let's say we need to do a whole bunch of these things, and we want to find the sum of the first 30 terms or the sum of the first 40 terms. And we didn't want to have to keep on going through these two steps. We could rewrite our s of n function, our s of n notation, using substitution. So we know that we're looking for u of n. right? That's the one that keeps on changing on us, the 30th term, the 35th, the 40th term. So if we want to change, or if we want to consider that, we know that up here we already have our u of n already worked out for us. That's u of 1 plus n minus 1 times d. So as we rewrite this, we can say n over 2 times u of 1 plus u of n. And u of n, as noted above, is u of 1 plus n minus 1 times d. So we can just plug that into our series formula and simplify n over 2 times 2 u of 1, because add them together, plus n minus 1 times d. This is actually using a composite function. We've now put one function inside another, right? And so that makes it a little bit easier than just using the result of one function like we started with. So now we can just have a whole new formula that all we have to do is plug in and solve. So let's see if this works. So our s of 25, the sum of the first 25 terms, is going to be 25 over 2 times 2 times our first term, which is also 2. So 2 times 2 plus 25 minus 1 times 5, n minus 1 times d. And as we keep on working this out, 25 over 2 times 4 plus 24 times 5, 25 over 2, let's see, we get all that together, 4 plus 120. Well, that's 124, which we had right up above. So 20, and we already know the result of that. That's 1550. So this is working out for both of these formulas. And the only difference is, instead of going through the blue formula and finding the 122 and then taking that and putting it into the red formula, we just created a whole new formula, so we just worked it straight through right from the beginning. So let's see how this works using actual function notation, okay? So we've got f parentheses x. And the way that we read this is we say f of x. We can also say f is a function of x. Okay, so that's another way of saying this. So a composite function is when we've got two functions, f of x and g of x. G of x is just another function that we have. And we're going to put g of x inside of f of x. So this is like in the previous, where we put the u of n, the formula for the u of n, inside the s of n function. Okay, so we could write it this way, and we could say f is a function of g of x. Right? Before f was a function of x, but now we've replaced x with g of x. So f is a function of g of x. Another way that we write this is f of g of x. So that's another way that we can write it. So you can see it in either of these two notations, f parentheses g of x, or f open circle, which is kind of like f of g of x. Okay, and this is also saying the same thing. So what's happening with both of these? Well, in both of these, the g of x is going inside f of x. Okay, that's the big thing to keep in mind. So let's look at an example. If we've got f of x equaling 2x plus 1 and g of x equaling x squared minus 2. If we want to find f of g of x, that means g of x is going inside f of x. So for every time you see x in f of x, g of x will replace that. So we start with 2 times x. So x is now the g of x, so that's going to be x squared minus 2, and then we add our 1 at the end. Now it's just a matter of simplifying. 2x squared minus 4 plus 1, and 2x squared minus 3. So there's our composite function. Right? So that's just like we did in the previous example with the arithmetic sequence in series. Took the one function, put it inside another, simplified it. Another thing you might see is f of g of 4. Okay, so this is the same thing. We're still going to use our composite function, but now 4 is going to replace x at the very end of this whole thing. So if you hadn't already done the composite function of f of g of x, then you would have to do that. But we've already done it here. So we would have 2 times 4 squared minus 3, because the 4 is replacing the x. See? So we're replacing it. So if you hadn't already done that 2x squared minus 3, you'd have to do that first and then plug your 4 in afterwards. But we've already done that work. And then it's just a basic computation of the numbers, 29. Now this could also work the other way. We could have g of f of x. And that just means the f function is going inside the g function. So now when we have our x, our f of x, it's going inside the g. And when we look at our function, we're going to start with our x squared. So the x is now 2x plus 1, right? So that's going into the x for the g. So we now have 2x plus 1 squared minus 2. Do our simplifying, and we've got 4x squared plus 4x plus 1, and then that's minus 2. And we simplify from there, and we've got our composite function g of f of x. So that's kind of how composite functions work. This is more using function notation. The previous example was using a different situation, but still using the ideas of composite. Hopefully you can connect the two and see how they're working with both. I hope that helps, and we'll see you in the next video.